Hi, I'm Daniel Bogdanoff, and welcome to the first day of Wave 2020. We are streaming live from Colorado Springs, and we have an action-packed morning for you, so make sure to stick around. Coming up shortly, we'll draw the winners of today's prizes. Each weekday between now and March 13th, we are going to give away test gear to 11 people per day, over $300,000 of gear total. If you haven't signed up, go to wavekeysight.com for your chance to win, and check back here every weekday to see if you're a winner. Each day's video will also have a fresh test gear tip or interesting test gear measurement. Today, Sarah is going to show us the impact that your microwave can have on your Wi-Fi signal using a signal analyzer. Is it an urban legend, or can a microwave actually impact your Wi-Fi speed? Let's find out.
Hi, I'm Sarah, and today we're going to explore microwave radiation with our analyzer. Well, I guess it's actually microwave radiation. Have you been having connectivity issues with your Wi-Fi or Bluetooth devices? It could be because your router or device is too close to a microwave. Microwave ovens, Wi-Fi, and Bluetooth all operate on the same 2.4 gigahertz frequency band. There are lots of other devices that can create interference in the same frequency band too, like baby monitors, electric blankets, cordless phones, my grandma's denture cleaner, the AI-powered toothbrush, connected litter box, and even smart flip-flops. But we won't discuss those today. Let's take a look at the Wi-Fi and Bluetooth signals traveling in this building with our Keysight FieldFox handheld analyzer. In Spectrum Analyzer mode, I've centered the FieldFox on 2.45 gigahertz with a span of 100 megahertz. This baseline signal you see here is the noise floor of the instrument. We know there's Wi-Fi and Bluetooth information in here, but those are intermittent signals that are hard to catch in the typical Spectrum Analyzer mode. If I toggle my Bluetooth to on, it sends out access points for pairing. You can see those spikes here. What we can't see very well are the Wi-Fi access points. So I'm going to switch to real-time spectrum analysis mode, or RTSA, which is basically a special gapless acquisition system that some analyzers have. Now that we're in RTSA mode, you can clearly see the Wi-Fi access points pulsing here. Every so often, we also see a wider signal that sweeps across the screen. This is Wi-Fi data transfer. You can also see the Bluetooth pairing signals here. What effect does a microwave oven have on these signals? Let's find out. Don't worry, I brought the popcorn. An ideal microwave wouldn't leak any radiation, but that usually isn't the case. You can see on the FieldFox how dramatic the leakage is. The microwave signals are much more powerful than the Wi-Fi and Bluetooth signals, creating interference in the frequency band. The question is though, does it matter? Let's see the impact on my phone's Wi-Fi speed. Here is the speed of the microwave off, and here's the speed with the microwave running. My Wi-Fi speed is much slower with the microwave running. During those times when the microwave is used a lot, like during lunch at work or when you microwave a turkey for Thanksgiving, power emitted from your microwave oven can have a negative effect on your wireless devices. One solution to this would be to upgrade your Wi-Fi to 5 gigahertz, or steer clear of the microwave oven when you're talking on your Bluetooth headset. Interference is everywhere, no matter the network you operate on. Testing for interference in your network impacts planning, design, and implementation. In order to prevent performance problems, quality issues, and outages, be sure to test for interference. To find out more about interference, read the white paper, Investigating Interference Issues in the Field Using RTSA, linked below. Thanks for watching.
Thank you, Sarah, for putting that back together. She'll also be back in a few days with another RF tip for us. And I think this year we have some of the best tips we've ever had. There's some great ones in the queue. You can also try this microwave measurement at home, even if you don't win a FieldFox this year, maybe next year. All you have to do is run a speed test on your 2.5 gigahertz Wi-Fi network with and without the measurement running. Or with the microwave running. I actually saw my speed drop at home from 80 megabits per second down to 12. If you try it, put your results in the comments or in chat. I'd love to see those. Speaking of the chat, we'll do some live Q&A at the end of the stream. Aaron, who you may or may not have seen on this channel before, is working the chat as we speak. We'll be collecting your questions and comments, and we can answer those in the Q&A at the end after we draw today's winners. So put your questions in chat now. Remember, make sure to go to wavekeysight.com to get your entry for the sweepstakes and access to the Wave exclusive resource libraries. We've handpicked some of our favorite ebooks, white papers, and app notes and put them all in one place just for this event. We almost never put everything together like this, but for Wave, we pull out all the stops for you. If we go and look at those and we get to the here's one of the resource libraries. You can see this is for oscilloscopes. But if I go back to wavekeysight.com, and I'm just going to do this live here. That should be tab 1, if I can get that window selected. There we go. We're on my PC. So on the Wave page, one of the things you can do once you've signed in is you can come back each day and get a daily entry. I'm going to get mine now. All I have to do is hit that Enter Now button. And I now have an extra entry for today. And every entry I have is included in every drawing, so you don't have to come back every day to win, but you would miss out on the tips. We'll also embed the live stream here, which I'm not going to do for bandwidth issues. But if you scroll down, we have a ton of these resource libraries for essentially all of the prizes that we're giving away. You know, you can win scopes, power supplies, etc. And if you look at some of these, you know, we have one for oscilloscopes. There's some app notes, white papers, ebooks that the team has put together. They're essential reading, in my opinion. I highly recommend you check them out. We also have a ton of these power supplies, multimeters, function generators, data acquisition units, signal analyzers or spectrum analyzers, signal generators. We just have a ton of different resource libraries out there with handpicked app notes, ebooks, white papers. And speaking of our prizes, this year is also one of the biggest prize pools we've ever had for Wave. Thanks to you OG folks out there. You can win one of 5 DSLX 1204G scopes every day. We're giving away 5 of those each weekday. We're also giving away 5 of these U1282A 4.5-digit handheld multimeters. And one winner each day, Monday through Thursday, will get their choice of a Tier 2 prize. We're calling them Tier 2. Those options, there's a 500 megahertz 3000T touchscreen oscilloscope. You've seen that a lot on this channel. I absolutely love this scope. I use it all the time. You can win an N6705C power analyzer with some power supply modules and an E-load module. There's a 7.5-digit DMM. This is one of the most precise, accurate DMMs out there on the market. I have one over here behind me. You could also win a 2-channel 120 megahertz function generator with ARB. It's fast, 120 megahertz, 2 channels, it's a great ARB. There's also a DAC 973A, which we just released this DAC like in the last month or two. You can win one of these with a couple modules that go back. We have some multiplexer modules, there's a DMM built in, there's all kinds of DAC options out there. So if you win a Tier 2 prize, that's Monday through Thursday, you get your choice of those. Each Friday, we also have a Tier 1 prize drop, and that's the big mama prize giveaway. There's an N918A, like Sarah used in the tip earlier. That's a 26.5 gigahertz Field Fox, which is a network analyzer, it's a signal analyzer, it's a cable tester. You can do S-parameter measurements, real-time spectrum analysis type stuff. The Field Fox is just, it's always a crowd favorite. Friday. Also, one of your choices is a 6 gigahertz oscilloscope. That's a 6004A. It has a different front end than the 3000T, but it runs on that same MegaZoom ASIC that all of our Infinivision scopes run on. This is a fantastic scope for doing some of those higher-end digital skills, having to go to a full built-in Windows-based oscilloscope. You can win a 5002A 9 gigahertz network analyzer. This thing is tiny. Basically hold it in your hand, carry it around, throw it in a backpack. Make sure you cap your inputs if you put it in your backpack. You don't want to zap your inputs, but that's a port network analyzer or an N6705C power analyzer. And this has an SMU module. So with that power analyzer, it's like the ultimate IoT or battery test solution. It's great. And on the Tier 2 prizes that didn't make it to the B-roll is also a RF signal source. So if you win Monday through Thursday, remember we're picking one of those per day, Monday through Thursday, you get your choice of all of those. We also get some frequently asked questions that we get them basically every year. We've been doing this event for a number of years. There's a link for the FAQ in this video's description and at the bottom of the Wave page, but I'll take about 30 seconds to answer a couple of them for you now before you have a chance to ask them. First, yes, this is real. Pinch yourself. You're not dreaming. This is actually happening. We're giving away tons of gear. Every entry is included in every drawing. You don't have to come back every day to enter that day's drawing, but it sure helps your odds of winning. The third question we get, when does the day reset? The day resets at midnight Mountain Time. So that's when the web refresh will happen. That's when you can get today's entry button to show up again. And we'll have a brand new video at 10 a.m. Mountain Time right here on the Keysight Labs YouTube channel each day between now and Friday, March 12th. Notice that daylight savings time does kick in for us next weekend, so there's an hour shift in there between this week and next week for some of you, depending on where you live. I know we get people from all around the world for this. And fourth, the question we get is, should I tell my coworkers? Is it going to hurt my odds of winning? No, tell them it's not going to hurt your odds. And if they do win, you will forever be the person that got them free test gear from Keysight. So it's kind of a win-win. And it's almost time for the drawing. You've been so patient so far, or at least I assume you have. I haven't looked at the chat yet. That's Aaron, but that's coming later. We'll do some Q&A at the end. But before we draw winners, we have one more test gear tip for today. Since it's day one, we thought we'd throw in a bonus, and then we'll draw winners. So sign up now if you haven't yet at wavekeysight.com. Also, there are a lot of new faces or usernames here, so we decided to pull a video out from the vault. I put this tip together in 2018, and it explains a phenomenon that absolutely stumped me when I first started here. Dave Jones would call it a trap for new players. It's about making sense of a function generator's output impedance options. When I started at Keysight, one of my first roles was doing technical support for oscilloscopes. And what that meant was I got exposed to a lot of the questions that oscilloscope users and function generator users like yourself asked, and things that confused them. And one of my favorite questions that I got that baffled me for a while was, why is my function generator outputting double the specification voltage output that I'm telling it to send out? So I thought I'd set that up today and we could take a look at why this is happening. So let's look at our setup. On my function generator, I have a 10 kilohertz, 1 volt peak-to-peak square wave, and I'm piping that right out of a BNC cable directly into my oscilloscope. And we can see I'm getting a square wave, and this should be a 10 kilohertz square wave, but my peak-to-peak voltage is 2.12 volts, so roughly 2 volts. That's double the 1 volt I'm telling my function generator. So why in the world would my function generator say 1 volt and my oscilloscope measure 2 volts? Is something broken? Is something wrong here? Well, the oscilloscope I know isn't broken, and I also know the function generator isn't broken, so there must be 2 volts coming out of the function generator. And the reason this is happening is because the output load on my function generator is set to 50 ohms. So let's go ahead and change it to the load output to high Z, which is what my oscilloscope expects. And you can see that my amplitude went up to 2 volts. So let me pop it back down to 1 volt. I'm going to go to parameters, amplitude, and I'm just going to drop this down to 1. And we can see on my scope it's changed, and I have a 10 kilohertz square wave still, but now my peak-to-peak amplitude is just 1 volt. So in high impedance mode, I'm getting normal voltage like I expect, but in 50 ohm mode, I was getting double the voltage. So what's happening? To answer that, we're going to have to go to the board. Let's start with a simplified schematic of my function generator. So this is going to be my function generator, and you basically just have your voltage source and a terminal here. That's kind of your negative terminal. And then you have a 50 ohm resistor here. This is sometimes variable. Often it's just 50 ohms. It depends on your function generator. And then when you're in high impedance mode, all it does is spit out that signal. And when you go to measure it, you're basically measuring plus minus right here. So if you're coming in with your oscilloscope, it's seeing this. And that's that 1 volt square wave that we're seeing now. Now, something special happens when I go into 50 ohm mode. What happens is the function generator expects there to be another 50 ohm load resistor right here. So this is 50 ohms, and now really what it expects you to be measuring or expects you to be powering is these terminals right here, so plus minus V. So now what you get is a voltage divider around this point. So you have 50 ohms here, 50 ohms here, basically setting your function generator to a 1 volt 50 ohm output. You're telling it you want to see 1 volt right there. So what it's going to do is it's going to output 2 volts, 2 here, and that way your voltage divider is going to split this in half, and it's going to give you the 1 volt that you actually want to see. So that's why when you put your function generator into 50 ohm mode, it outputs double the expected value. We could show this by putting the scope channel into 50 ohm mode, but for the sake of time, we're going to avoid that. And a quick recap here, in 50 ohm mode, the function generator expects a second 50 ohm load, so it's going to output double the voltage. So unless you're working with 50 ohms, a 50 ohm termination, don't use 50 ohm mode. Use high Z mode. Because when you're working in high Z mode, the output of the function generator is going to match the specified value on the screen. So we switched back over to the bench. We're setting up for our Q&A at the end of this video, so make sure you have questions in chat. And now it is time to draw today's winners. We're drawing winners every day. These are just the first set of 11. There's actually 44 more winners after today, so make sure you are signed up on the website. You have all your information there, and you are eligible and entered to win. So today's winners, I'll first say also we get a lot of questions about this tool every year. It's sufficiently random. We've vetted it with legal teams, so I'm not going to go into the specifics of how we draw names, but just know it is a random draw. We've looked at this tool very closely to make sure that no one's trying to gain unfair advantage. And now that we've all drawn, okay, today's winners of a DSLX 1204G, we have Michael Daniel, Marino Gennari, Imrich Morve, Anton Julia, and Etienne Riom. Congratulations to our winners. You won a 200 megahertz DSLX 1204G 4-channel oscilloscope. The winner of the U1282As, we're giving away 5 of these every day also. We have Michael Graves. That name rings a bell. I think he might be here on this channel for at least a couple years. Darian Rodriguez, Przemysław Bodis, Hezam Izika, and Douglas Ripka. Congratulations, you've won a U1282A. And our big prize for today, it's the Tier 2 prize, we're calling it. You get your choice of all kinds of different gear. There's a blog on the Wave page. You can click on that blog and it lays out what we're giving away and when. It also has links to the FAQs and all that kind of stuff. The winner of the Tier 2 prize today is Richie Williams. Congratulations to our prize winners. We also, as we transition back into Q&A, so if you have questions, there's last chance to put them in chat. I'm gonna head back over with Brig, who's a regular on our podcast, the Double E's Talk Tech podcast. Actually, let's roll a clip of the Double E's Talk Tech podcast while we transition back to Q&A. While we transition to Q&A, I want to highlight the Double E's Talk Tech podcast, which is available wherever you get your podcasts. The most recent episode is an interview with none other than Mr. Mehdi Sadaghdar, or Electroboom himself. People either love podcasts or they hate them. I personally like them when I'm doing something manual and a bit brainless, like shoveling snow or doing the dishes, or even the rare occasion that I hit the gym. We launched Season 2 right after Thanksgiving, and we're going to wrap it up in the weeks following Wave, so make sure you're subscribed to the podcast. If you're wondering what it's all about, it's best summed up in the Season 2 trailer. So let's make like 3M and roll the tape. Hi, I'm Daniel Bogdanoff, and to date, there are 37 episodes of Double E's Talk Tech. Well, 38 if you include the quick interview we did with the astronaut, but it's been over 6 months without a new episode. So you're probably thinking, come on, Daniel, get your act together. First off, that's a little harsh, but fair. I won't hold it against you. Second, since Mike and I started this podcast in 2017, I've had at least 4 different jobs at Keysight, and this podcast hasn't really been a part of any of them. It's more of a passion project inspired by over-the-cubicle-wall conversations about tomorrow's technologies. And if you've been with us for a while, you know that our publishing schedule has been about as regular as a Zapped 555 timer, but it's been a blast. Sometimes literally, like the rocket launch coverage from episode 29, or the interview with the BattleBots winner in episode 27. We've also covered ADC development, quantum computing, power integrity, radar, technologies so new we legally weren't allowed to say their name, and a full suite of high-speed digital technologies like USB Type-C, DDR5, PCIe 4.0, and we are not done. Technology never stops, and neither will we. Double E's Talk Tech Season 2 is coming soon, and it is shaping up to be a banger. Coming November 21st are 8 episodes in 8 weeks covering topics like 5G, the recently announced USB 4 spec, and more quantum computing, as well as some interviews with Jay Alexander, our heavily patented CTO, and the king of electrical shock hazards and master of the universe, unibrow, Mr. Electroboom himself. We might even do some editing this season, and Mike even wears a different shirt. Gone are the days of wondering when the next episode is coming out. Gone is my sense of guilt as the episodeless weeks roll by. Season 2 drops November 21st. Subscribe now wherever you get your podcasts, or watch the video versions over on the Keysight Podcast YouTube channel. All right, so we're back. We have Brig. Brig, can you? We're gonna do some Q&A. So I have the chat pulled up. Aaron has been collecting questions, and this is a more casual thing. So feel free to hang out. If you have questions, let us know. Put them in chat. I also saw BitLoonies here, so shout out to you. If you don't know the BitLoonies Lab channel, go check it out. He does some great builds. He has this giant ping pong ball wall where he hooked up, I think it's like the NeoPixels behind half ping pong balls, and you can do video stuff. It's super duper cool. So anyway, shout out to you, BitLooney. Brig, can you introduce yourself?
Sure. First, let me second the shout out to BitLooney. And so my name is Brig AC. I manage the planning and marketing organization inside of Keysight that focuses in on high-speed digital and networking.
Awesome. So Brig is a regular on the Double East Talk Tech podcast. It's doubleeasttalktech.com. And he has a full team of people that work with him that cover all of the new and upcoming technologies. Some we can talk about, some we can't talk about. So I kind of brought him on, and we could talk about some of the new and upcoming, what's coming in 2020 and in this decade. But I also want to first address some questions from the chat, and then I'll come back to you.
All right, that sounds perfect.
Brig does a great job of sitting there and looking pretty. So, okay, we got a question. What kind of lab power source is best for a DIYer, beginner, or a computer electronics enthusiast? So I personally like having a triple output power supply. There are also some single output power supply options. There's one back over there on the bench, and they're kind of small single output. But with those, you have to really be careful picking the right voltage and current scales, because power supplies are rated for a wattage, current times voltage. So there's a max current and a max voltage setting. So there's some DIY options out there that are really great if you're just getting started, but if you're working with sensitive boards or devices you don't want to blow up, I highly recommend getting an actual benchtop power supply. Do you have one at home? I know I have a couple at home.
I just have one at home, but it's not a super nice one.
Okay. Another question we got. We mentioned we had white papers on our site. Are any of them on RF antennas? I should have read that before I answered. I don't know off the top of my head, but almost certainly.
Oh, for sure, we have RF antenna white papers out there.
Yeah, there's also some stuff on EMI and EMC. We actually have a new blog that just went up in the last week. I think it's 4 tips for making EMI and EMC simple, and it talks through some techniques for measuring that. So shout out to Jessica for putting that blog together. This is a good question. Usually PC designers put around their board vias connected to ground because they decrease EMI radiation. My question is, do they actually work? And if they work, how well do they work? Do you want to speak to that, or do you want me to?
You go ahead.
Okay. So yes, they do work. The big thing is, if you have you basically want to ground your boards everywhere possible. So when you're going to lay out a PCB, you do these pores basically of copper. And when you do these copper pores, they're on different sides of the board. So connecting the two together, especially around transmission lines or between chips that are sending out high-speed data, getting that grounding really, really helps a lot. There are some great webcasts on vector network analyzers and signal integrity measurements that address vias and different types of vias, because you don't want to go halfway down, switch over to a different layer, because you get some weird reflections and stuff going on there too. So we have a whole webcast series. If you search Keysight webcasts, we have probably almost every week, maybe more frequently than that, a webcast of some type. And I know for a fact there are some signal integrity ones out there that I recommend you check out. What else? Okay, someone said, for what kinds of signals is using the intensity graded feature useful? So one of the things that scopes have is you can set the. Do you want to talk to it?
Oh, I can definitely talk to that one. So
go for it.
So there's a couple different things that work really well for it. So first off, if you're looking for something that doesn't happen very often, you can use color grading to see to potentially catch a signal that you haven't seen very often. Color grading works really well for real-time eyes. If you want to get into advanced signal integrity things, you can start with the color grading, and you can see where where signals are hitting really often and where they're not hitting very often, and so you can get some views on that way. Color grading actually will also work if you're doing some FFT RF type measurements. that you're looking for like strange anomalies and just kind of getting a statistical, basically a statistical input of how often the signal's hitting different places. And so honestly, there's a lot of different places where, color grading is very useful. Getting back to like where the glitches were, back before scopes were running 1 million waveforms per second, it was kind of the only way to see a glitch. And when you're running 1,000 waveforms per second, just occasionally you use color grading and it would pop up and you'd be able to see it. Now it's become a little less useful, but still a very useful tool for those kind of things.
Yeah, and the 6000X, which is one of those Friday prizes, has color grading on it. It's beautiful. You can even do like color graded FFTs and stuff like that. The other Infinivision scopes have an intensity display, so it's not color graded, but you can still see how strong. You can control how bright a trace shows up on the screen. It kind of is a throwback to analog scopes, where old analogs. I don't know if you said this. I was reading chat. I'm sorry.
I'm only a little offended by that.
So basically, analog scopes, the less frequent, the dimmer it was on the screen. Someone also commented on the vias. Michael Lorenzi said, the general rule of thumb is to place grounding vias less than lambda over 10 apart to provide good EMI shielding. So thank you, Michael, for that tip. I will say it definitely depends on your bandwidth and your systems and what you're working with, but having some of those rules of thumb is definitely super helpful. Someone else asked, does your bandwidth drop with increased channel output on an oscilloscope? I'm going to kick this one to you.
Yeah, so that's a great question. So your bandwidth doesn't necessarily drop. The scope bandwidth's going to be more or less fixed. What does drop, though, with the channel output is how much you can actually use that bandwidth. So as your channel output decreases, the usable bandwidth that you actually get out of the scope actually decreases. So the bandwidth will stay steady, but you may have, let's say you have a really wide oscilloscope of 50 gigahertz, but you have very limited channel power. What you're actually using of the scope bandwidth is somewhere in the 15 gigahertz range or even less than that. And so that's where your channel power can really impact your bandwidth. So the scope bandwidth stays the same. The usable bandwidth, if that makes sense, is actually what is limited in that case.
Interesting. Okay. Someone asked, is my basic PC oscilloscope still usable? Is it functional? Is it okay to use? Should I save up for something else? We've seen a lot of people take a sound card from their oscilloscope and essentially turn the sound card into a PC-based oscilloscope. If you have nothing, it's better than nothing. But I highly recommend, if electronics is something you're going to dig into, spend some time, or you're working in a professional environment, you absolutely should spring for a bench oscilloscope. I've used both. I have a little Raspberry Pi oscilloscope that I've played around with. There's just no replacement for a bench. And of course, I'm going to say that, but it's true. Go on the forum, check out the EEV blog forum. There's like every other day a thread, like which oscilloscope should I buy? And they talk through a lot of these things. So I highly recommend going to check, just play around with one and see maybe a makerspace has one, or your company, the R&D folk down the hall have some. I don't know. Some other questions. Let's see. Someone asked about what probes they should use. The scopes generally come with some passive probes that work in a lot of cases, but if you're doing specialized measurements, getting a current probe or a differential probe. Actually, Electroboom, I think, posted a video this morning, or if he hasn't, it's coming up very soon, and he actually talks through probing and when to use differential probes, all that. What about probing for something that's just incredibly fast? What are the probing options out there?
Yeah, so you have a couple different kinds of probes for something that's really fast, and it all depends on the probe architecture. And so probes can go up to 30 gigahertz as far as bandwidth goes. And then you have some other, like, if you just consider, probing's general, right? So we're talking active probes here. But you could even consider something like a cable as a probe in a way.
Yeah.
And there you're getting into the hundreds of gigahertz with some of the cables. But from the high active probes, you have two different architectures. There's one that's called a resistive capacitance, or RC architecture, and that's really good for if you're doing memory technologies, MIPI, those kind of things. And then there's also one if you just want raw bandwidth as fast as possible. There's what's called an RC architecture, and that's good for technologies if you're doing PCI Express or 100, 400 gig, those kind of things. But those are the very high speed. If you're down in the low bandwidth, the big thing to really consider is impedance. So do you need a mega ohm or do you need a few hundred kilo ohms kind of thing? And that'll make a big difference as far as what your probe is.
Yeah, and when you get to high speeds, doing that impedance matching is really important. And then you also have a probe loading factor. So, you're looking at me like you said that already. I'm sorry.
No. I don't think I said it very as well as what you just said it.
So
I was trying to get to that, but I didn't use the word probe loading. So
okay,
I take full blame for that one.
So essentially, when you hook up, it's going to load your signals. It's going to load your device. It's extra impedance that's not supposed to be there, and it can throw off things like oscillators and stuff like that.
Yeah, it actually happens a lot with probing that people just think that if you put a probe on, that it's just your signal, and they don't even consider the fact that you're adding a huge amount of impedance to your signal when you put a probe in these, especially when you're looking high speed. So that probe loading really is critical.
Awesome. Someone asked, actually, James Langbridge. Hey, James, it's been a while. I know we shared some emails. For color grading, do you have options for colorblind people or folks with achromatometopsia? I assume that's a color deficit of some type. I don't know. Essentially, for color grading, there's different like heat scales you can use. So if you're not so good at, if you have trouble with a certain color, you can change that gradient. On the scopes, you can't really change the channel colors, but one of the things I saw somebody do is they actually, it's not recommended, they took the scope apart and they swapped like the red and the green lines to the display, and it basically remapped all of the colors, and changed it to a palette that they could differentiate better. So that was a fascinating little hack that I saw on that.
Yeah, one other thing you could do potentially to hack a channel color is, the scopes have a bunch of functions in them. And so you could do a magnify and do a one-to-one magnification, and then functions, you can change the colors on them. And so it'll slow the scope down just a little bit, but you can change to basically any color you want on the channel. And like you said, Daniel, you can adjust the color grade to whatever you want as far as the colors goes inside of the color grading.
And on the screen, it also, it says what channel that is, which is, in a pinch, you can do it. I play a lot of board games, and they're all about like symbols and colors combined. So like red always has the symbol, and that's, kind of that sort of key exists for scopes as well. Somebody asked, when, if ever, do you want to use an isolation transformer on your oscilloscope? We put together a power supply app note group about how to measure and test DC power supplies, and it addresses when to float a scope and when to not float a scope. I'll come back around after this stream is over and put a link for that in the description. I think there's also a video on that too. Johnny Hancock put together some fantastic power supply testing videos on this site. So there's a couple questions in chat about like DC to DC converters and that sort of thing. I highly recommend you go search, switch mode power supply testing. On our channel, we have probably dozens of deep dive videos into power supply testing from the last 5 years or so.
Oh, absolutely.
So we've done some great work there. What other questions do we have? And we only have a couple minutes left before we're going to cut the stream off, so get your questions into chat now. Hey, James, good to see you again. A lot of people saying that they love Keysight and love the prizes. We're just thrilled to be here and bring it back to you. I highlighted another question in here that I wanted to answer, and I'm trying to find it. Someone wants more information on how to control a salvage stepper motor for an old dot matrix printer. One of the things, if you're trying to salvage parts, is salvage parts that you can read the part number on, and then go find the data sheet and read what's happening there. So typically you can desolder parts. A Great Scott did a video on what's worth salvaging and what's not worth salvaging. So I know many of you also watch the Great Scott Lab channel, which fantastic. We love his stuff. I watch every one of his videos when they come out. And he did a shout out to Wave and brought a lot of you here. So thanks to Great Scott for that. And if you're here from that channel, welcome. He did a video on what's worth desoldering. EVblog, or Dave Jones, does a lot of those also. The other channel I would give a shout out to is Electro Noobs. He has a huge Instagram channel, so if you're an Instagrammer, go check out Electro Noobs. He also has a YouTube channel here where he does some fantastic builds and talks through some of these, salvaging parts and some of these questions that I'm seeing in chat. There are some questions about Wi-Fi and the tip that Sarah put together, Wi-Fi and microwave radiation. Someone says, if microwaves affect Wi-Fi speed, does it also affect Keysight instruments like the oscilloscope itself? So can you talk a little bit about just in general EMI and how it matches up to test gear?
Oh, sure. Yeah, so EMI is consistently a problem for test gear as well, which you would expect to happen, right? I mean, we're dealing with EMI on a daily basis or an hourly or minutely basis with our test gear, and so we consistently have to deal with EMI type issues. And when you think about it, like if you're probing, let's go to the scope again, if you're probing down on a signal that might have some emissions out of it, you really can't afford to have that scope be impacted by the emissions. And so we actually spend a huge amount of time when we're designing our scopes to make sure that they're protected to not have that EMI come into the scopes and impact your signal. Because the last thing you want to do is use the scope to try and debug an EMI signal, and then there's some emissions coming out from somewhere else that's causing the EMI issue. So we have to be really careful with that, and that's the same thing, especially on the RF gear. We talk scope specifically here, but the reality is we spend a ton of time just looking through EMI, and then if you look at like the EMI testing, there's entire standards based on making sure that the gear is EMI proof, if you will, for test and measurement.
Awesome. Yeah, so someone asked in chat, what's the difference, why would I use a spectrum analyzer or a signal analyzer versus the FFT on an oscilloscope? And I've been dying to do a video on this, actually.
This would be a great video.
And you've been working on the UXR, that's our new 110 gigahertz oscilloscope, which is just mind-blowing technology that it even exists and is possible. But can you talk a little bit, you've been working on this.
I have.
Spectrum analysis versus time domain analysis and how they kind of are different and the same. Can you speak to that?
You bet. So one of the big fundamental things that's always been out there is speed of measurement. So a scope is kind of clunky. It's especially when you get into the RF gear. That's been improved a lot over the last few years. And so now what you're seeing is the scopes, when even measuring on RF signals, you can dial down into very specific bandwidths and use stuff which is like digital down conversion to speed up and make it to where it's about the same speed as even a spectrum analyzer. You're seeing some scopes come out with real-time spectrum analysis, which basically puts you at the same speed as a spectrum analyzer. And then the question comes down to, hey, signal integrity-wise, is the scope much worse than a spectrum analyzer from a signal integrity standpoint? And the answer is, it depends. And so this is why this would be a really good podcast, is because it depends on the measurement that you're making. If you want to make a measurement that's really wide and you want best signal integrity for a really wide signal, the scope does a phenomenal job. If you're worried about like third order intercept or signals like that, ACPR, that's where the spectrum analyzer is world class when it comes to those type of measurements. And so it's not as simple as the spectrum analyzer is always the best thing or the scope is always the best thing. That you really got to understand what your lab environment is, and then the answer is it depends on what you're doing.
Fair enough. Fair enough. And if some of those terms like third order intercept or total harmonic distortion, some of these RF terms are a little new to you, we have a video series on this channel with Ali called Ready, Set, Measure. There's like 8 or 10 of them that go through how to make these measurements and what they actually mean with a signal analyzer. I'll commit to pulling into one of those videos as a tip, maybe a bonus tip on one of these days. One of the most popular videos on our channel is what is total harmonic distortion, which is an essential RF measurement. So I'll pull that tip in later in this week.
Yeah, I was just making up measurements. I hope they were. Okay.
Yes, I know. You're more of like a digital scopes guy historically, so you're branching out a little bit.
That's right.
Someone asked, does the length of the probe affect your measurements?
So that's a great question too. So the answer is no, and there's a reason for that. So the length of the tip of your probe, that actually does make a difference. So if you have a really long tip from the probe head to the actual signal, that tip is definitely going to impact your bandwidth of your scope, and it's going to impact your measurement, your signal integrity. If you're running directly into the probe head, we actually compensate for all the loss of the probe. And so that's not going to impact your bandwidth other than what it says in the data sheet. So that loss is already taken into account, and so that probe data sheet is going to tell you exactly how we impact that measurement.
Great. I also want to give a shout out to DefPalm. He's here. He does electronics repair on YouTube, and he has a great channel. I think it's underrated. So go check that out. He's based, I think, in New Zealand. But shout out to you. Somebody asked, why we with our scopes, we combine a lot of things. We have a DMM, we have a function generator, we have all this stuff built in. Why don't we have a power supply built in? And this is something I was wondering myself. But if you look at a power supply, if you break one open and tear it apart, the fundamental backbone of a power supply is this massive toroidal transformer. So to put that into a scope, you're almost doubling the weight of your scope and power draw. So that's something where we just kind of it's not, no one would be happy. You might think you want it, but no one actually wants that in their oscilloscope. And bench supplies are so small now too. Go ahead, sorry.
Oh no, you're exactly right. I mean, it just comes down to space. Power supplies take a lot of space, and we just haven't wanted to dedicate that kind of space to a scope that, it would be extremely useful to have it, but it's space that's really the killer there.
Be a bit of a nightmare. So I want to transition over to a little bit. What tech is coming in 2020? What's kind of the new cool stuff that you and your team have been working on?
So now we're going to go into what is cool around really high speed kind of things.
Yeah.
So technology-wise, there's a big thing inside of data centers.
Okay.
That they're moving to a faster speed, going from 100 gig into 400 gigabits per second.
That's Ethernet?
Yeah, that's Ethernet. Yeah.
Okay.
Sorry about that.
No,
Yeah. So that's Ethernet. And then if you go into the high-speed digital side, you have USBs moving to USB 4, PCI Express is moving to Gen 5. But on a more technology-based thing, the fun thing that's really kicking off, and we did a podcast about this, shout out to our podcast.
Yeah, wstalktech.com, wherever you get your podcasts and your favorite podcast engine.
That's a phenomenally good shout
Yeah,
out
I
right
should have
there.
brought the W's Talk Tech mic.
Yeah. But so we're quantum computing actually, as far as research goes, we're actually seeing a lot of activity around quantum computing on the research side. And then there's always the other stuff that you read every single day, autonomous driving, and then of course, big shout out to 5G as well. Because 5G is really becoming reality right now. It's down at the low speed 5G. We haven't gone up into the millimeter wave, and that's coming over the next couple of years. But we're seeing lots and lots of activity around 5G as well.
Yeah, so on the 5G topic, right now we're basically up to 6 gigahertz of bandwidth, but the 5G spec goes a lot higher. Are we able to talk about what speeds it's actually going to?
Sure.
You mentioned millimeter wave.
Yeah, so 5G gets into millimeter wave, which is in the US, it's defined as 28 and 39 gigahertz are the two bands for 5G. Beyond that, though, they've actually even put out a 5G bandwidth up at 60 gigahertz. The problem is at those kind of bandwidths, the waves don't travel through walls and things like that, and it's a really difficult technology. Plus, it's really expensive to build an entire infrastructure at those kind of speeds, and so that's why you're seeing the 5G rollout sub 6 gigahertz right now. And the goal, of course, is to get up into the 28, 39 gigahertz, and you're actually even seeing kickoff now of even 6G. Starting to
6G?
happen. Yeah.
What do we know about 6G?
We don't know very much about it. It's very, very high bandwidth.
Okay.
And it's a long ways away because 5G is going to take a long time to roll out.
Yeah, there's some significant challenges, especially in the millimeter wave frequencies where, if the air has too much humidity, you lose transmission capabilities. Or I saw a really cool demo at a trade show where someone had a 5G antenna and they were showing the signal basically on a scope or a signal analyzer. And then they closed a plexiglass door in front of them, and you could still see everything, but then you saw the signal just drop to zero because it doesn't go through windows. So it's going to be really cool to see that roll out. And we did a podcast on 5G. We also have another video coming out on this channel that's kind of a wrap-up of when we went to CES that talks into more of this 5G stuff as well, because I've been deep diving into 5G the last couple months, and it's crazy.
5G is just kind of a fun topic if you... you'll see articles every once in a while in the newspaper about 5G, but the more you dive into it, the neater it is, and just to watch how that technology can evolve over the next few years is it's fascinating.
Yeah, and the thing I've been seeing is there's PR 5G, and then there's engineering R&D 5G.
Absolutely, huge difference.
And there's a Grand Canyon between the two, because everyone wants to say, we have 5G, but it's tricky, especially as we get higher up. And technically they do, because you're getting up to 6 gigahertz and all that, but to see it down the road where it's actually going is going to be really exciting to watch it roll out. Okay, one or two more questions. Let's talk. Someone says 5G is unnecessary. People say that about every technology as it comes out, right? Why do I need 400 gigabit per second? Why do we need we find a way to use that data. If we're streaming in 1080p, knock it up to 8K and then stream it over your handset while you're sitting in your autonomously driving car, and you're gonna want that bandwidth.
Yeah, I think that's really true. I mean, if you're just going out and looking at YouTube, yeah, probably 5G isn't totally necessary. If you're running sensors out of a farm somewhere to figure out what the humidity is inside of that farm, or you're autonomously driving down through the streets of New York, yeah, that's where the 5G speeds are absolutely needed. And it's speed, but it's also the latency of 5G is so much better than what it is of 4G and LTE. And so that's, for those kind of technologies, that's where 5G becomes much more important. For day-to-day use, you and me, I don't know how much of a benefit it's going to, for our phone streaming, that kind of thing. I don't know how much we're going to care that much. But for a lot of these other technologies, that's where 5G becomes much more necessary.
Absolutely, and I'm trying really hard not to geek out on 5G right now because we're almost out of time. Can you briefly talk about PAM4?
Oh, sure.
So that's something we're seeing for PAM4 and beyond, I guess, for 400 gigabit Ethernet. So essentially, with a digital channel, you have a 1 or a 0, but now designers are like, no, I want more than a 1 or a 0 on a line.
Yeah, so what's happening is, we've been going 1 0 1 0 for a really long time, and it turns out that it's really hard to do that as you get above 30 gigabits per second as far as speed goes. And so designers are trying to figure out new ways to push more bandwidth through that same limited channel. You can't afford always to put the most expensive material into a board when someone wants to pay, I guess now $1,200 for a cell phone, but before it was less. But so there's only so much money that can be out there for these things. And so designers are like, how do we push more bandwidth through the same channel? And that's why we do PAM4, is because essentially in the same channel, I can double my bandwidth through PAM4.
Right.
And so that's really what we're doing. Now, the problem is, though, if you are a designer inside of PAM4 is, yeah, you're doubling your bandwidth, but you think about a real-time eye for 1 0 1 0, it's about yay big. And this is to scale, but in PAM4, you actually have something you've got 3 eyes in that same kind of space, and so you think about like from a signal to noise ratio, it gets really difficult to do that from a design standpoint. So it's not just like, hey, I'm going to do PAM4 and now I've doubled my bandwidth. There's a lot of other signal integrity challenges with that.
That makes sense. So I'm gonna make the executive decision. We're about out of time. Thank you so much, Brig, for
thanks so
being
much for
here.
having me.
We're going to be back every weekday for the next 2 weeks at 10 a.m. Mountain Time on the Keysight Labs YouTube channel. So make sure to subscribe to this channel. If you like podcasts, if you really enjoyed this conversation, we have like 40 episodes of the podcast over wherever you get your podcasts, so go check that out. And that's it for today. So thank you so much for watching. I'm Daniel Bogdanoff. Thank you, Brig, for being here.
Hey, thanks again for having me. It's been great, so thank you.
And I'll see you right back here tomorrow.